Hello everyone, uh, I'm Dr. Mohsen from KFU IT Rahim Yarkhan. Today we are going to discuss global navigation systems. How is GNSS used in precision agriculture or in other engineering use, civil engineering, agriculture engineering, and agriculture purpose? What is georeferencing and the guidance? Mapping, scouting, and sampling. It is used for soil and tissue test, crop scouting, yield mapping, and variable rate control. What is guidance? Guidance, the use of GNSS position and speed to determine the path of travel. The display and the monitor is based on create and manage the guidance pattern. Lightbar help stay on intended path of travel. Why use a guidance system? Decrease skips and overlaps, minimize driver errors or human error, eliminates gas rows up to 8.5% row crop situation, increase efficiency, operate at faster field speed, cover more acre with fewer hours of operation, reduce per acre fuel consumption. It is non-economical benefit. What does guidance provide? Accurate guidance for all field operations can be achieved on the basis of georeference by GNSS. This system make it possible to guide machinery precisely along virtual line while respecting boundaries. Boundaries can be georeferenced in uh, a prior pass around the field. Once stored and mapped, they are available for several years. What are the type of guidance pattern? Fixed, width or straight pattern, prior pass, adaptive curve. Straight pattern or the AB pattern creates a line by setting a predefined AB point. Guidance path appear parallel to your set line. Additional trips are defined by a given offset, typically the operating width of implement. Prior pass guidance. Each run across field follow respective prior path offset by a given distance. A driver starts by manually steering machine just as usual on a first path, a so-called gas row along the field. Once the prior pass has been recorded, all other trips across the field follow on the basis of GNSS. Codes of all passes are georeferenced in order to get the following run. It has some limitations. Adaptive curve, similar to prior pass, driver set a point and creates B point by changing heading. Deviating from path will update guidance line. Guidance path will update based on the last pass. Which one fixed width guidance isolates error, but topography and field shapes often do not allow an exclusive use of fixed line guidance because topography will provide issue due to fixed line with implement and the GNSS positioning. What's out there? Manual fully operated control, light bar, automatic system, assisted steering wheel is controlled mechanically, integrated, use vehicle, electrical, hydraulic steering system, technique rely on GNSS signals for the identification of cross-track error, deviation of the horizontal distance to the reference line, light bar, cross-track error are indicated in an LED display arranged in a horizontal row. Error that occur in pass to pass depends on driver chase mode versus the pull mode. So here are the description of the GNSS accurate GPS positioning system. This part described integrated GPS with the standard ESD guide is provided here, and this is the display, and this is the light bar or the it's a bright LED system. Assisted steering, mechanically turned steering wheel, allow for hand-free steering, improve pass-to-pass accuracy, can install without removing steering wheel. Automatic system similar to light bar, except signal to go to electric and hydraulic steering actuators. To engage the automation system, the driver push a button, system takes control and lead vehicle along the closest guidance line. Operator must control speed. It's also used when here in the mention in the picture if I'm sorry, Dave. I'm afraid I can't do that because in case if you have no lightning in the as in agriculture there's no lighting, you are working in the field, you will lose the accuracy. So these guided paths will help you stay at in your room and just auto steering system and GNS operated system continue to work in your field. Automatic system in principle, some assistant guidance system can also be used for turns. Many farmers still use it only for passes across the field and steer manually at edges. Shortly before a machine arrives at the edge, a sound reminds the driver. After having completed the manual turning, driver again pushes the button for automatic control. Problem and solution on the slope. The technique that was dealt with the prior work well on flat land. Large portion of the global agriculture area is slope. This makes precise guidance more difficult as compared to the flat land here in our Punjab. Dealing with slope, generally receiving antennas installed on the roof of the tractor, some distance above point at which implements for most farm operation work. On slope, this distance results in additional error of georeferencing. A control algorithm that are based on the same slope have to correct this error. Dealing with slope, in case of slope, the red dot here, the target point describe the line where we want to apply this input or whatever the operation we want to perform. But the target shift due to the fixed line, it will not consider the slope or the slope level. So we need slope based georeferencing actuator or the sensor that will automatically work with that. System for correcting the downhill drift rely on either passive or active steering of implement. Passive guidance correction steer somewhat away from path. Active guidance corrections are made by steering division on the implement itself. So the passive implement guidance is presented here. The slope, in case of slope, still it is working on the accurate position. It is the implement is drifted directly to the point of application, not just working in the center of the tractor. So steering filters implement GPS antennas presented here at how the machines work under precision agriculture. Thank you very much. These type of GNS are not only used in precision agriculture. As I'm dealing with remote sensing and GIS courses and the precision agriculture also, these can be also used for mineral exploration, identification of the rock types and other minerals, organic content, organic matter, and soil classification, soil taxonomy, whatever you are going to measure or you can work. In case of any question, you can ask me on the Google Meet during lecture, or you can put your question on my YouTube channel. So I will respond very quickly to answer your question. Thank you very much.